Tonight we're going to learn 4-9, isosceles and equilateral triangles. Last section of this chapter. Okay, objectives. Prove theorems about isosceles and equilateral triangles. Apply properties of isosceles and equilateral triangles. Recall that an isosceles triangle has at least two congruent sides. The congruent sides are called the legs. The vertex angle is the angle formed by the legs. The side opposite the vertex angle is called the base. And the base angles are the two angles that have the base as a side. Okay, so your legs are the two congruent sides. The angle that is included in those congruent sides is called your vertex angle. All right? The side across from your vertex angle is the base. And the angles that are with that base are your angles 1 and your angle 2. Isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite the sides are congruent. So what this is saying is the angle opposite this side is C, angle opposite this side is B. Therefore, angle B and C are congruent. Converse. If we have a triangle with angle E and angle F congruent, what that is saying is the side across from this angle is congruent from the side across this angle. So segment DE is congruent to segment DF. All right, the length of YX is 20 feet. All right, that's already identified for you. Explain why the length of YZ is the same. So we think that this right here is 20 feet. Well, how do we know that? So we need to think isosceles triangle here. Okay, so this angle right here is 140. This angle here is 40. We need to know what this measurement is right here. Well, so that's the measurement of angle YZX. Well, this is a linear pair. So what we can do is we can take 180 and minus the 140 and find the measurement of that angle, 40 degrees. So if this angle here is 40 degrees, what we can say is YX is congruent to YZ because the converse of your isosceles triangle therefore, if XY equals 20 feet, so does YZ. Find measurement of angle F. Measurement of angle F. Okay, well, we've got an isosceles triangle here because of these two tick lines, so we know that these two angles here are congruent, right? So, measurement of angle D equals measurement of angle F. That is your isosceles triangle. Actually, let's do this. Let's say angle D is congruent to angle F. So we have the converse. Okay, so we have measurement of angle E plus measurement of angle D plus measurement of angle F equaling 180 degrees because of your triangle angle sum theorem. So let's identify this as a variable here. And angle E is 22. And let's solve this equation. Okay, x equals 79. X is the measurement of angle D and angle F. So the measurement of angle F equals 79 degrees. Okay, I'm going to be quiet on this one and see if you can solve it on your own. Okay, the following corollary and its converse show the connection between equilateral triangles and equiangular triangles. If a triangle is equilateral, then it is equiangular. How do we know that? Because if all sides are congruent, then you know that the side opposite this is congruent to the side opposite this because of your isosceles triangle theorem. Okay? So if these sides are congruent because of your triangle angle sum, you also know that that one is congruent. And then the corollary of the equiangular triangle. If you have all three angles congruent, you know that all three segments are congruent. Okay, so let's look at this. Find the value of x. Okay, well we know that triangle LKM is an equal angular because all three sides are congruent, so all three angles are congruent. So, we know that the measurement of angle L equals 60 degrees. So what we can do is we can substitute in 2x plus 32 and set that equal to 60. All right, find the value of y. I'm going to be quiet and see if y'all can work this one on your own. Okay, using coordinate proof. Prove that the segments joining the midpoints of two sides of an isosceles triangle is half the base. All right, guys, I'm going to have to stop this and do a part 2. I don't think I have enough time.